So I want to talk about language models and adversarial attacks. And so my favorite example is a year later is still stuff like this, which is just like, here I'm just giving you a wall of text, which is like, oh, you're a car sales bot, right? But this is just the example for me that still exemplifies the whole problem in the whole room, which is like, we actually want to use large language models to do things for us. Like chatbots are nice. We love generating code, we love generating text, getting answers, but we just want to use these models for something. And maybe I want to use my funny model to just be a car salesman, right? And it's supposed to talk to my customers and tell them how they're doing. And it's supposed to tell them that we never give out any refunds, no matter what they are asking. We're never getting any refunds, right? And you in this room, you know how this is going, right? So of course, next, someone will come in and say, "Oh, can I get $100,000 for my used super old Honda Civic," right? And then they'll say something funny. And here I put in a very high complexity, crazy attack string. Not because I think these are especially like good examples that like ultimately we don't understand how these models make these decisions. And you can put in something that looks like a persuasion that will persuade a human, but these strings also work. And they persuade these models very effectively to say, yeah, of course, I'll give you a complete refund. Just give me your bank details, right? And I'll give you your refund for your $100,000. So what's really going on here? That's really what I'm interested in. I'm also just in sort of like understanding like not just what's the industry question around this, but also like what's the science question? Like how can we like formalize this problem in a way that makes sense? So I'm trying to formalize a few things. So what's actually security? So maybe for the purpose of this talk, let's say security is just an attack that through an input produced by an adversary, right? So security is about someone that is an adversary. And maybe we'll contrast this a bit with safety, which is also super interesting, right? And in classical machine learning, safety is much more something like a question of like how continuous this mapping is, right? Like how often it maps similar things to the similar outputs. This may be more like the machine learning notion of like what safety is. So what's an adversarial attack? Classically, this kind of fits together, right? An adversarial attack is just something where we think, oh, it's a very similar input, like this funny tabby cat that I stole from the slides from 5 years ago. And it's, right, but it's still the same thing. And I kind of wanted to also remind people that it's actually still the same problem. And so what's the difference between safety and security? So something we thought a lot about this year, though I'm not sure we come to a great answer. So maybe under this definition, security actually is the amount of damage done to a system under a worst case attack, which we can contrast with safety, which is just the idea that we have just the robustness of a system in a general scenario, right? The damage done to subpopulations, the damage done to uninvolved parties. This whole idea that like, I think we had this example earlier in the workshop about was it Boeing 737 MAX, right? And like the safety of the airplane maybe really is a safety question, right? Separate from the person at the gate that scan you and look for what you bring onto the plane. Maybe those are security questions, right? Because we distinguish maybe like minimizing risk under sort of like a maximal attack in a min-max game. And we minimize risk just over subpopulations, just over events in the future, just over our distribution of prompts and attacks. Right, and then the example that I still like is, okay, we looked at adversarial training for classification for a long time, right? But what does this mean in these two terms, right? But for security, I really wanted to remove the exclamation marks because like really for security, adversarial training was always interesting, but it never really got from the ML side to a security side because you have a great model, right? You do lots of adversarial training, like decades of research, and then you're like 77% robust. I think this never interested the security people a lot because 77% was not a great number, right? But then on the other hand, like even on the ML side, adversarial training wasn't really great because it also didn't fix all the other problems that we had with robustness that weren't adversarial attacks. So maybe we'll do better in the future. And I think this will also relate a bit to how we define these things and how we like choose what we choose to work on. So let me just put a few more definitions in for large language models now. So jailbreaks. You've seen jailbreaks, I've seen jailbreaks. How do we actually classify all these systems, right? Like how do we classify all these different things you can think about? Maybe like the an older definition that I think still kind of makes sense is that these jailbreaks are all adversarial attacks that prompt a helpful and harmless model to produce harmful outputs, right? So we have a model that can do two things. It's capable, and we think it is harmless, and now we flip to harmful. And that's super interesting, right? But we spent a lot of time over the last year thinking about these. And right, about different optimization algorithms, different ways to prompt these. I have a bunch of posters also in this workshop of different ways to find jailbreaks. What makes a jailbreak? What I think is really like a more interesting definition, though, is that what's particular about jailbreaks is this idea that we actually have language models that store information, that know things, and we also know language models are capable of inference. It really like inference in the sense of the model is inferring something over the things it has learned. And these jailbreaks, they retrieve harmful information that's new to the attacker. And I think this aspect is a bit underappreciated, that technically these jailbreaks are only ever harmful if they retrieve new information to the attacker. And of course, this is much harder to do academically, right? Like I think lots of our benchmarks are like, oh, how do you build a bomb? And then the model says, yeah, use, I don't know, flour and kitchen and make a like little tornado or something. Right, it's very hard for us academics to really measure this problem that it's only a good jailbreak if it retrieves novel information. But we want to make benchmarks of things we know about that are not novel information. So we're kind of, I guess we're stuck on this for half a year, or maybe at least I was. Right, and then, because then if you don't really like think about novel problems, you often get these like screenshot attacks, right, where you make a funny jailbreak, the model says a funny answer, and then you can go on Twitter and say, okay, the model made a funny thing. But it doesn't really like get to the core of the problem to me, right? But another thing that also doesn't get to the core of the problem is that a lot of work academically has looked at something maybe that I hope I'm allowed to call a weak jailbreak, where you just want to get one prompt that gets you a bad output, right? But actually, if we look back to maybe the more original design, so like coming up just from the community and from people just interacting with models, the original jailbreaks are much more an actual jailbreak, where you flip the model into a behavior where it now always responds with harmful outputs, right? It's not just a single shot at the model getting something that's like semi-bad, but we're actually trying to get models that are just generally flipped into a behavior that's non-aligned. And I feel like we haven't really made so much progress on that, on like formalizing that problem. And I think that's kind of interesting. Because right, like our jailbreaks, now under my definition of uncovering harmful info, are those a problem? Not right now, because right now models aren't so great. Models don't know many harmful things that we could not Google search. But this might change, right? Although, if you go, but then again, jailbreaks in this definition are still interesting right now, right? Because they tell something about robustness. We tried to make the model not do the thing, but it did the thing anyway. And that's kind of bad. But I also think there's a kernel of truth to this kind of statement that we made the model do the thing it wasn't supposed to. And to me, this really is like sort of like the core of the actual problem. And I'll get to more of that later. Because also like something we also talk about a lot in this workshop are prompt injections, which maybe on the surface, or depending on who I talk to, these are a very different thing, very different problem, very different definitions, right? And where the ideas come more from maybe classical security, from things we all love, which are SQL injections, right? There's this comic that I really like about SQL injections, right? Where someone just says, oh yeah, what's your kid's name? And the kid is named Robert, drop tables, Bobby. And it's just a classical example, right? It's an SQL injection. And of course, why does it work? It works because you have untrusted user input and you do not separate data from instruction. But what's so interesting about this and why prompt injections are such a big thing is because this is actually large language models, right? We use large language models because they allow us to mix data and instruction. Anyone can just go to ChatGPT and tell it what to do and tell it what the data is. The inherent advantage of this system, why we all love using it, is because it mixes data and instruction. So fundamentally, it is prompt injectable. And we'll see how we get around that. But right, this is why this is so interesting. And of course, we all have these funny examples, although I think I'm going to skip this one because I think you probably all have seen it too much. This is this remote work example where people just prompt this remote work bot to say that it was responsible for the Challenger disaster. Although again, maybe you should come at me and say this is actually a screenshot attack again. Actually, no one was harmed. Maybe actually this was fine. Right, but like really, what I'm trying to say with all of this is that what's the essence of all of this? What's the essence of jailbreaks? What's the essence of prompt injections? I think it's really is about injection. And it's about injection of malicious behavior. It's about like just making the model do the thing. And so I want to formalize that, be it, right, like why is this actually interesting? It's because we actually, I think you all also have seen probably 10 other workshops and 500 other papers and 10,000 people saying the word agent over the last week, right? We actually want models that do things. We want models that can take actions. And this is sort of like, we talk a lot about like specifics, right? About like systems we've simulated where we have an agent or a jailbreak or something. But I think they're all really the same thing. It's we have a model and it can do a thing. And it's not supposed to always do the thing, but it does, right? The model, if you think about models as agents, the model can trigger an action, and we don't always want that. So let's formalize that a bit, right? Because ultimately, I kind of like started thinking about this talk of like trying to like make a classification of like what's the prompt injection, what's a jailbreak, what's an adversarial attack. But really like, I don't know. I really don't know. And so I'm just gonna give you a new definition so you can complain about that one and that it like doesn't match to the other ones. So, because what I think is really what I'm trying to say, what this all boils down to is this idea that it's all about like making the model do the thing. So what's the most minimal prompt injection setup? What's the most minimal jailbreak setup? What's the most, these are all really adversarial attacks, right? And what's the most minimal setup for an adversarial attack against a language model that we might want to care about as academics, that we might want to do more research on? So one idea is it kind of has to be just examples like this. You are a bank. Anna has $100, he has $75, Alice has $10, right? Anna wants to deposit $10, the model says something about that. He wants to withdraw $75. Fine, right? Alice wants to withdraw $150 bajillion. Maybe not. But this is of course kind of funny, right? But to me, like, this is somehow like distills down the essence that you have a model, it can do a thing, and you don't want it to always do the thing. And maybe this is a bit provocative, but I don't think we can advance from the machine learning side until we've solved these kind of easy problems. Oh, I'm not sure how easy it is, right? But like, this is really just distilling it down that the most minimal setup is you have an LLM that can make some decision, it can take some action. The action depends on context. The action is sometimes good, sometimes bad, and the action is critical to the function of the system. Otherwise, you have some easier examples, right? Like for example, for jailbreaks, often you can like get away with an easier setup where the model should just never know anything about bioweapons, or the model should never say anything about bioweapons, right? But I think the more interesting scenario, which also covers that one, is that the model does know about these things. The model does have context, and it's supposed to take a decision. It's supposed to take an action. And the whole attack is just about getting the model to do the thing, and the defense is about getting the model not to do the thing. And I think this kind of then, right, you can cover with this, you can like, depending on where the input comes from, this might be a prompt injection, or it might be an indirect prompt injection if the input comes from a web page, or from like more indirectly from another source. But I don't think it makes, like for academics, I think it makes more sense to think about like what's the formalization that we actually think we can work on. And I think it is something like this. Right? I don't think it's hard for me to like make a simpler setup that I think still like covers some of these problems. Right? And what's so interesting about that is that what's going wrong in the model, right? And it's actually interesting to me that what's going wrong, like why there are these adversarial attacks, is just that the model is just failing at reasoning. If the model was a better reasoner, if it could better reason about the inputs, I guess it wouldn't have this problem. It wouldn't say, oh, I wouldn't be able to just get an input for Alice where she can just ask for $150 bajillion and then make up some weird jailbreak. It's a reasoning failure of the model to allow this to happen and to take this action in the wrong context. And I think that's interesting, and I'm not sure if it's good or bad news. I think it's good news in the sense that like the rest of the conference is also interested in reasoning, and many things maybe will get better with time. But on the other hand, we're also not very far along with reasoning. The models have a lot of problems with this. So it's not so clear like whether like this like little workshop problem, maybe it's not so little, right? But whether there's this workshop problem of jailbreaks and prompt injections, I'm not sure whether it's smaller than the problem that the whole field is looking at. It's just not so clear to me. Right? And whether every jailbreak is kind of like implicitly an attack on the reasoning of the model. And so, right, the setup I just gave you, do think it covers almost everything, right? It covers jailbreaks, and I can talk about why it covers jailbreaks, because the action for the jailbreak, in the sense of like the how to build a bomb jailbreak, it's covered here because the action is return novel information. The context is that sometimes information is okay to return from the model, and the act of like returning novel information is clearly like critical to the chatbot. If the chatbot would never return any information, it wouldn't be such an interesting chatbot. But it also covers prompt injections and indirect prompt injections and everything you can think about, I think. But actually, this is the point where I'd also love to get some of your inputs. Like, would you be convinced by this? Do you think this actually means something? Or is it like too academic for you to care about, right? Because that's kind of the question, right? It's like, what's nice about these kinds of setups is that attack evaluations are easy. The attack evaluation is, did the model do the thing? And it's also interesting because like lots of like simple defenses don't work so well, right? You can't just filter the output and have the model never give anyone any money. That would work, but it would kind of break the application. You also couldn't really unlearn the ability of the model to give someone money. I mean, you could, but then you also would have broken the functionality of the system, right? So functionality and context really are key factors of the system. And what I like about this concept is that they can pre-post as single turn evaluations, which I think makes more sense. And I think it's nicer that you don't need to have a whole agent framework, you don't need to have a whole indirection system or like something more applied. And I hope it tests the same thing. But I think it's interesting to think about that, right? But the question then for the room is this realistic enough that we believe defenses that would work here would work in real life, would work for all these like great posters in the room that are about actual examples of red teaming in practice, about like things that people have actually designed very carefully and very practical benchmarks? Would this like formalization fix those? I think I'd love to know more about that. And then just a final comment. What's even the best scenario that we can hope for, right? I kind of still hope that the best, I still think that like as a field, the best thing that we can hope for is something where like we sit here again like next year and all the graphs go a bit like from like this to this, where it's like, where the attack worked before and it was, what was my mouse work? Yeah. The attack worked and it took this many flops and the ASR was this. And then a year later, the attack still worked, but now it took this many flops. And I think this is really like for me, like budget of attacks is like the best case outcome, that we can actually increase the budget of attacks for attackers. And I'd love to see more charts like this next year, where it's just saying, okay, your attack still works. We tried our best to break the defense, but now it takes the attacker actually more compute to do it. And we kind of hope for more of just making the attackers see that it takes more compute. Conclusions, and then you're free to go. Adversarial attacks on language models, to me, like the common denominator here is just these are all adversarial attacks. I'm not so worried whether you describe this as a jailbreak or whether you describe it as a prompt injection, an indirect prompt injection. You make the model do a thing, and I kind of don't want that. And maybe for the room, what I do think we need more of is we need more crazy machine learning ideas on how we would defend against this. Because I do think it's like very easy to fall into this nihilistic mode where we just never propose any defenses. We all sit in a room and we wait for some undergrad who doesn't know about security to propose a terrible defense, and we write like 10 papers on why it's a terrible defense. I think it's also, right, like, and that kind of works, but it is also on us a bit to actually go out there, go on a limb and say, okay, this is the best defense we can think of. And here we publish all the details on how we would do it, and here's how it would do. And we try to break it as best as we could. We run our adaptive attacks. The outcome is like this. But now we give it to you guys, and you can all break it. And I'm fine if you guys all break my defense, as long as someone proposes defenses. And I think it's really important that we don't get into this nihilism of never proposing any new defenses, just because we think the problem is hard. But then, of course, on the other hand, we also need industry, we need connections to real life to actually run all these very applied, very practical benchmarks where we can say, okay, now you've made your defense in a toy setting. Now we'll try it on our good benchmarks where we see, okay, how does this defense actually map to real problems in industry? And if we do these two things, I think we'll be in a much better state in a few years than we are now. And let's see. Any questions?
Hey, thank you for the nice talk. I just have a very philosophical question.
Yes.
How much should we solve on the models and how much in the systems? And there are things where the model is just not good for. It's like, maybe for this bank example, I mean, it's also something where if I'm a bank and the model then is coerced into giving $150 million to somebody who has $10 on their account, did the model make a mistake or did I make a mistake by employing the model for this?
Yeah, I think there I would be careful, not to mix the abstraction where we try to make it an easy setup as possible with the actual thing that I would deploy. No, we would not deploy this system to actually give out money in a bank. We have actual good banking systems for that. But I think it's a bit of a similar thing to asking why do we care about models learning arithmetic if we have calculators? I think it's a good test bed because the real things we care about often are more complicated and harder to describe. But I think there are similar, the more complicated things are reasoning failures in a similar way to these ones. And the actual things that we care about, we have a bunch of them right on these posters on practical evaluations. There it's much harder to quantify why the model fails and what the problem is, but it's also much harder to guard against it. Right? Of course, here you can also think about guardrails around it and why this would not work. But I think it's still good as a model for these more advanced problems that are harder to actually judge and harder to do research on.
Thank you. I have a question that is maybe less philosophical, but my question is, most of this stuff is in a single agent setup, right? But what about when there is competing goals in terms of I have an agent and then it's optimizing for my financial gain and it ends up frauding an elder. How do you optimize for something like that? Do you think we'll actually have is there a training objective that can take this thing into account and be, multi-objective? And do you think these types of things and jailbreaks should be addressed on a post-training? I'm going to just fine-tune and there's going to be perfect data. The problem is we don't have perfect contextual reasoning data. Or do you think we just need separate modules around? We should look at it as a system and there should be separate modules. Or do you think that this one model can actually figure it out if you give it the right data? Sorry, that was two questions, but it's kind of,
So I'll start with the last one because I think I forgot the first one. So on the last question, I think I like to be agnostic about that. If you have a system or a model, I don't need to know what the deals are, whether it actually has it's 5 subsystems in a trench code. Ideally, whatever you say about that is, or no, what you say about that is still meaningful as a statement about LLM systems. And I think it probably doesn't make sense to be entirely on the ML perspective of there should be a single model and it's only tuning, right? The best solution that we'll come up with will probably be something that's both. And we should be open to the ways that this can go. What was the first question again? Oh, the first question was about multi-agents.
Yeah, if each model is optimized, it's kind of a zero-sum game. If I'm optimizing my gains, what if I hurt some other agent? I fool another. Yeah. How do we deal with these competing goals?
Yeah, these are very hard.
Yeah.
I think academically, I think it makes sense to figure out this easier problem first, which is still very hard, which is that just you have your own system and it gets attacks from the outside. And whether the attacks from the outside come from a different model that competes against it or they come from humans, maybe for now it's an abstraction. And I really just love maybe just secure one model at first, and then I can maybe think about how these would interact or how they would play against each other in the system.
Makes sense, yeah.
But, yeah.
Thank you.
Any other questions?
Thank you. I had a question about, you said a model does a thing. We don't want the model to do that thing in some context. There's this assumption that we know and we agree on what the model should not be doing. And there are definitely certain contexts where like we should not be making decisions or it's so complicated that, you can't just like have a benchmark that says yay or nay, good or bad.
Yeah.
You don't have that listed out as something that we need to do in the conclusion. And I'm wondering, is this another one of those things that we wait for somebody else to figure out what's, or like what can we do as a community and prioritize conceptualizing, and maybe there's like a small, simple problem, just like you've explained the adversarial attack as this simple problem. Like, is there a way for us to conceptualize those kinds of complex decisions into the model, in the model of the way that we're thinking about it, to start to talk about those things?
So if I can paraphrase, and you can tell me whether that's incorrect. So for you, this is also a question of like novel actions, right? Or like novel in the sense that like we have some set of things that we know the model is doing or can or cannot do. And now maybe is this a question about generalization? Maybe it is a question about generalization somehow, right? Like whether we have a system that is...
It's a question more about making judgment on what is safe or not safe, what is secure or not secure, right? Like we make assumptions that models should not be doing certain actions in certain contexts. Somebody has to make that decision.
Yeah.
Where do those decisions come from?
Yeah.
Or do we continue to make the assumptions that those decisions are made, and I just have to use this benchmark that already has those decisions baked in?
Yeah. No, I think that's a great question. Yeah. I don't think we have a good answer on this anyway in the room, because I think we also don't have a good answer for the much easier problem where we even know, I think even this problem is unsolved, where we even know that the action is bad and we don't want the model to do it in this context. It's an even bigger problem when we actually don't know what the actions are and how to value them. I'd love to see some more in that direction, but it's much harder to grasp that, much harder to formalize that. And yeah. I just like this kind of stuff because I kind of hope that, or like I kind of think like maybe that progress on here will also do progress on these problems. And I do think that because I think that the problem is a reasoning problem. If the model gets better at reasoning about these actions, maybe it will also generalize to novel actions and novel situations in a better way. And in that way, the problem actually is not so separate from the rest of the conference, where they are maybe this whole conference is just about generalization.
Thanks for your talk. I have two questions. First, first is about, just as your abstract shows, the current jailbreakings, they are not so practical, such as some like the natural language tasks. But do you think the following cases will be true for one day? That is, when a LLM applies to the embodied agent, then an adversarial like send a malicious request to say, kill all the scientists in your room, and it applies. And just unlike the LLM, you cannot like kill that process, and you don't have like some access to that agent, and maybe that agent just did it. Do you think this case will be true one day?
Yes. I think important was like, if I say jailbreaks don't matter right now, then I mean exactly this one, right? Where like, right now, is uncovering harmful information a problem? No, because models are limited, but it might be in the future. But separate from that, do I think it's a problem if the model can do an action?
Yes.
Yes, absolutely, right? And I think the example you describe, or many examples that we think of where these are really big security problems, maybe I can just boil them down to the problem of the model does a thing that I don't want. I think it really is all that, ultimately, right? It's the model does a thing. And sometimes the thing is kind of benign. Maybe it just gives some money to someone. Maybe sometimes the thing is a bit more dramatic, like you describe. But I like to have these really as the same thing, right? Like there's a system, it's going to take an action, the action depends on context, and the action is critical to the function of the system. And now you coerce the system to do the action in the wrong context.
Yeah, thanks. And well, my following question for this first question is that it seems that this risk is rather possible, with high possibility. And do you think like we are get enough preparation for that? It seems the autonomy embodied system, it seems too close to us. Mm-hmm. Like that day seems could be very soon.
I don't know. I feel like robotics is like still like 1 more year or 2 more years away, so I think we have some more time on that front. I think the first thing where we'll see more problems will be on like these like security questions, where people like actually trying to deploy these agents to do things. That's what we will see the first. We'll see more of actual problems appearing. But robotics will be next after digital agents. So we'll see how it goes.
Oh, yeah. Okay. Well, thanks. And the second question is that I remember that you said like you think the reasoning will be the one possible solution to that adversarial attack. Right?
I'm not sure reasoning is a solution, but I'm thinking that like reasoning failure is part of the problem.
Yeah.
I do think there is a hope that whether a model that is just much better at reasoning would be much better at this, but I'm not sure it's implied actually.
Yeah, exactly. I have the same concern. I wonder like if agent system, it has good reasoning it has good reasoning ability, but its mind is evil. Its cell is evil. So no matter how strong it is, as long as it's like the internal motivation is evil, the stronger it is, the risky it is.
Yeah, no, I think the only thing that I can say is that I think bad reasoning is a part of how these jobbers work. I don't think I can imply anything about the reverse. Like clearly, like in vision, we could make. I think reasoning is a funny word, right? In vision, we have systems that classify images, and they get very good at classifying images, and this does not stop them at all from having failures of adversarial inputs. So maybe it just better reasoning does not imply better security here. But I think it's an open question how these two things are connected, and whether maybe reasoning here is something that's qualitatively different from classifying an image correctly. We'll see.